Good day there. Welcome to a video introducing equations and inequalities for Year 12 AS level maths, the first year of A level. So today we're going to have a look at what should be familiar to you pretty much already from GCSE, but we'll be taking this forward into new territory later in this chapter. So before we get on to the equations and inequalities proper, let's just recap with 4 warm-up questions. Here they are, 1, 2, 3, 4. Try them yourselves before looking at the video solutions which I've recorded for you in this video. Then once you've done them, just check you've got them right. If not, use this video to help you correct yourselves. So let's have a look at the solution to question 1. So for question 1, we're just asked to expand and simplify where possible these following brackets. So first off, we have 4 brackets 7x minus 9. So 4 multiplied by 7x is what we do first of all. That'll give us 28x. And then 4 multiplied by minus 9, that's going to give us minus 36. For the next lot, we'll do minus 3 times 5. That's going to give us minus 15. And then minus 3 multiplied by minus 2x. Minus multiplied by minus will give us a positive. So we get positive 6x from this one. For part B, we're asked to essentially just play a game of find the odd one out. So what we need to do first of all is to expand the brackets of this first one. So we've got 4 different equations. One of them will be the odd one out. So this first one, if we expand, we'll get 3x minus 3 equals 5 plus x. Rearrange to get the x's on one side, the numbers on the other. That will give us 2x equals 8. Therefore, x equals 4. And so from this first equation, once we've solved that, we get that x equals 4. For the second one, again we can rearrange this simply enough. And so subtract 3x on both sides. We're going to get that 2x, then add 8 to both sides, we get 2x equals 8. Therefore, again, for this one, x is also equal to 4. And so these first two aren't going to be the odd one out, because these first two both have the same solution, x equals 4. This one here, so we can rearrange this one, so get the x's onto the same side. So 4x take 1x is 3x. And then here, subtract 9 from both sides, minus 3 minus another 9, that gives us minus 12. Divide through by 3, we get x equals minus 4. And so 4, 4 and minus 4, it would appear that this one here must be the odd one out, because this doesn't have a solution of minus 4, this has a solution, so this does have a solution of minus 4 rather than 4. And so it would appear that the odd one out is this equation here. But what we should do is aim to verify that, to be absolutely sure, and just check this last solution before just assuming it's this one. So this last solution to this last equation here, 1 minus 2x equals x minus 11. If we add 2x to both sides, we get that 1 equals 3x minus 11. Add 11 to both sides, we see that 3x equals 12. Divide through by 3. We then, as we'd expect, find that this one isn't the odd one out. This one again gives us that x equals 4. And so this last equation here, again agrees with the first two that x equals 4. And so the odd one out is this third one. The top one, x equals 4. The second one, x equals 4. The last one, x equals 4. But the third one, which I've put in red, is the odd one out. For part C, we just need to make up any other equation that fits the pattern. And so as long as we make up an equation that has a solution of x equals 4, we're absolutely fine. So there's infinitely many options you could pick for part C. So one I've made up earlier, I'm going to go for 5x minus 8. So substituting in x equals 4, this has a value of 12. 5 times 4, take 8. That's the same as 16 take 4. 16 take 4 is 12. And so this is one of infinitely many solutions you could have picked for the equation. So just any other one which has a solution of x equals 4. This is one of many. let's now have a look at solving question 2. So for question 2, all we need to do is make y the subject, which means put these equations in the form y equals. For part A, we can subtract 3x on both sides to obtain that 2y equals 16 minus 3x. Then divide through by 2 gives that y equals 8 minus 3 over 2x, or 3x over 2. So that's the first one done, part A. For part B, if we add 3y to both sides, we get 9x equals 3 plus 3y. But to make y the subject, we need to have y written first. So then we can say 3y equals equals 9x minus 3. And dividing 3 by 3 on all sides, we get y equals 3x minus 1. And so that's part B sorted out as well. Questions 3 and question 4 are grouped together because essentially they're part of the same question. So for question 3, A and B, we have a table of values to complete for an equation. So we have y equals 5 minus x. So whatever x is, y is 5 minus that. So first of all, when x is minus 1, y will be 5 minus 1, which will be 6. Next, 5 minus 0 is 5. And I'm sure you'll see the pattern that it just goes down in ones each time. So this one here, filling in the grid, is going to look like this. We can now graph this equation by simply doing a line through any two of these points. And so we have minus 1 and 6 up here, and 6 and minus 1. So if we just pick these 2 points to graph through, the line would be something like this. We next do the same for part B, where y is x minus 3. So first of all, minus 1 minus 3 would be minus 4. 0 minus 3 is minus 3. And similarly, this has a pattern going up in 1 each time. And so, filling this in, we'd have something that looks like this. We can now graph this equation too. So we start down at minus 1, minus 4 here, and we go up towards 6 and 3, which is this point here. So what we need to consider next is where these lines intersect. So the points of intersection, in fact there's only one point you can see. So the intersection is here, and we need to label this. And so this point here where they intersect is clearly 4 and 1. So the point of intersection is 4, 1. So we've now completed those warm-up questions. Let's have a look at the lesson proper. So essentially today we're talking about linear simultaneous equations. So the first thing to mention here is that a pair of linear simultaneous equations in two unknowns, usually denoted by x and y, are simultaneously true for one pair of unique values of x and y only. So what do we mean by linear? Well, linear means the variable or variables have the highest power of 1 only. So an example of linear would be 3x plus 2y equals 14 and 2x minus y equals 8. The powers of x and the power of y can be rearranged so it's just x to the power 1 and y to the power 1 respectively. An example of non-linear would be where we have a power of x or y that isn't unitary. So for example, these here are non-linear. The bottom equation's linear, but because the top isn't, because we have x squared, considered as a pair of simultaneous equations, they're a non-linear pair. So, let's just consider this in a bit more depth. So just going on the intuition of us, for part 1, let's verify that the following pair of simultaneous equations are true when x equals 5 and y equals 2. So if we're told that they're true when x equals 5 and y equals 2, then substituting in x is 5 and y equals 2 for both should make both equations work. So let's just try this. And so for the top one, if x is 5 and y is 2, if we substitute these values for x and y in respectively, the equations should work out. So the top one becomes 3 times 5 plus 2 times 2. Just substituting in that x is 5 and y is 2. So 3 times 5 is 15, plus 2 times 2, which is 4, equals 19. So that checks out. It does say it equals 19, and it certainly does. But does x equals 5 and y equals 2 work for the bottom one? Well, the bottom one, 2x becomes 2 times 5, because x is 5, then minus y, so minus 2. What's that going to give us? Well, 2 times 5 gives us 10, then minus 2 from 10 does give us 8. And so again, this one works as we'd expect. For part 2, we need to create a new pair of linear simultaneous equations that are also true when x is 5 and y is 2. So, to be honest, you can make up anything you want. So what I've made up here, let's go for 4x. So 4x would be 20. Then if I took away 9 lots of y, I'd be taking away 9 times 2, which is 18. So 20 take away 18 would be 2. Now let's go for 3x. So 3x would be 15, then plus 7y. 7 times 2 is 14. So 15 plus 14 would give 29. And so that's just one of infinitely many other examples of a pair of simultaneous equations that would be true when x is 5 and y is 2. Let's now consider linear simultaneous equations and graphs. So just going back to question 3 and question 4 on the warm-up, we could see that from the graph from question part 4, there's only one point of intersection of the linear graphs y equals 5 minus x and y equals x minus 3. In fact, there'll only be at most one point of intersection if we've got two linear simultaneous equations. The only other option is if they don't intersect at all, or if the lines are one and the same, then there'd be infinitely many. But if they intersect and cut, they can only cut at one particular place. So going back to the equations from part 3 and part 4 of a warm-up, because they only intersect once, that means they're simultaneously true only at that point of intersection, which was x is 4 and y is 1. So to solve that algebraically, what we'd have to do first is to just rearrange them. So x plus y equals 5 and x minus y equals 3. So once rearranged, how would we then solve it? So there's actually two algebraic methods for solving linear simultaneous equations: elimination and substitution. We'll compare both approaches in the following examples we're going to do together. So let's have a look at worked example 1. So we've got two different equations simultaneously to solve: x plus y equals 5 and x minus y equals 3. So I'm going to just copy these equations down in both the elimination and substitution columns as such. Now we can solve them. Elimination means exactly what it says. Elimination means we have to just get rid of x or y by either adding both equations or subtracting both equations. And what we need to check first is that the coefficient of either x or y has the same magnitude. It doesn't matter about the sign, we can come to that secondly. So if you have a look here, both x and y, the coefficients have magnitude 1. So if you have a look at the y's, this is a positive 1y, this is negative 1y. And so what we could do here is add both equations. If we add these equations together, then what will happen is the y's will cancel out. A positive y added to a negative y, the y's will eliminate, which is exactly what we want. And so let's add these up, like I say. So x plus x gives us 2x. Y plus negative y cancels, eliminates itself. 5 plus 3 gives us 8. Dividing through by 2, we now see that x must equal 4. Once you've got that either x or y equals the value we've worked out, we then have to substitute that back into one of the initial equations. Which one you substitute it back into does not matter at all. So I'm going to pick the top equation. If you wanted to pick the bottom equation to substitute it back into, that would be fine as well. So now we're going to sub into the top equation. So the top equation was x plus y equals 5. But now, because we've worked out what x is, we know that x equals 4, we can now say that 4 plus y equals 5. Rearrange that, very simple. Obviously y has to be equal to 1. So the solution set of these is that x equals 4 and y equals 1, which is exactly what we got from doing the graph in warm-up question 4. This is showing algebraically that x equals 4 and y equals 1. Substitution is a different method which, although can be more awkward, is actually more versatile, especially when we have non-linear equations to solve simultaneously. So here what we do is we have to write either x as the subject or y as a subject. Which one you pick doesn't matter. It really doesn't. But what I'm going to do here is I'm going to pick on the top equation. So from the top equation we have x plus y equals 5. I'm now going to make y the subject. So we then have y equals 5 minus x. Once you've done that and made y or x a subject, we substitute that particular value, that particular expression rather, of y into the other equation. So now we substitute y equals 5 minus x into the bottom equation. So then what we get is x minus 5 minus x, because that's what y is, equals 3. This can now be rearranged and neatened up, and so x minus x, that's the same as 2x minus 5 equals 3. Add 5 to both sides, that gives us 2x equals 8. Divide through by 2, therefore x equals 4. Now we know that x equals 4, we can substitute this into the either top or bottom equation. So now we know that, we can substitute it into either. So let's pick the bottom this time. So substitute into the bottom equation. What we'd get now is that 4 minus y equals 3. Therefore, very obviously, y must equal 1. So we've got the same solution set. We've arrived at x must be equal to 4 and y must equal 1, like we got from doing the elimination method. So you'd expect the final answers to be the same, but here you can see the different approaches to both. Let's have a look at a second worked example. Again, we're going to do this both by doing elimination and then substitution. So we have 3x plus 2y equals 14 and 2x minus y equals 8. So here, I'm just going to copy down these equations into both columns like I did earlier. So here we go. Now for the elimination, we can see that sadly, the magnitudes of the coefficients of x and y aren't the same in both. So we could either try and get the x's to be the same magnitude or the y's. So if we have a look at this bottom one, that's minus 1, whereas here y is 2. So if we doubled the bottom equation, that would give us minus 2y, which is the same magnitude as positive 2y. And so what we'll do first of all is move forward. So moving forward, we'll leave the first one as it is. Essentially, we'll multiply that by 1. This one, we're going to double everything on the bottom. So leave the top as it is, times that by 1, This one, we're going to times everything by 2. What we have then is going to be 3x plus 2y equals 14. This bottom one, when we double everything, will become 4x minus 2y equals 16. Now we've got that, we can add both equations. We add when the magnitudes are the same and the signs are the opposite. If the signs were the same, if we were both positive 2y, we'd subtract one from the other. But because both are different signs, we add them. So here, I'm just going to make a note of what we're doing. So here we're going to add both equations. So 3x plus 4x gives us 7x. The y's cancel, they eliminate. And 14 plus 16 gives us 30. So therefore we see that x must be 30 divided by 7, which can leave us 30 over 7. As ever, we then sub this back into one of the initial equations. If you're not sure which one to pick whichever equation looks the easiest to you. I would say this equation at the bottom looks a bit easier than the top one. So I'm going to sub x equals 30 over 7 into the initial bottom equation. So by bottom equation, I just mean this one here. So if x is 30 over 7, 2x will be 30 over 7 times 2, which is 60 over 7. Then minus whatever y is, must equal 8. Therefore, y must be 4 over 7. If you don't want to do this in your head, in fact, even if you do like doing it in your head, always use your calculator to double check. So if ever you see me doing calculations on here, and I'm not using a calculator, it's not because my mental arithmetic is particularly great, it's okay, but it's because I've used a calculator to check beforehand, just to speed up the recording. So over here, what we'd be doing is 60 over 7 minus 8, which is why we get y is 4 over 7. So putting those pieces together, we've got x, which is 30 over 7, and y, which is 4 over 7. So the solution set is x is 30 over 7, and that y is 4 over 7. So let's try this using substitution. So by substituting, we can then put the value of the expression into the other equation which we've not used yet. So we can use either x or y. So what I would suggest is, if we use this bottom equation, just because it's easier looking, we can rearrange to make y the subject. So if we add y to both sides and then subtract 8, we'd see that y is 2x minus 8. So because we know that y is 2x minus 8, we can then substitute this into the top equation. And so that's what we do next. So we sub y equals 2x minus 8 into the top equation. So then we have 3x plus 2 lots of y, which is 2 lots of 2x minus 8, because we worked out that y was 2x minus 8 by making it the subject. That equals 14. So expand and simplify. So we have 3x plus 2 times 2x is 4x. 2 times minus 8 is minus 16. Equals 14. 3x plus 4x is 7x. Add 16 to both sides, we get 7x is 30. Therefore, dividing through by 7, we get that x must be 30 over 7. We then proceed exactly as before. we then substitute this back into one of the initial equations. So I would say to just substitute this into the bottom equation again. So sub x equals 30 over 7 into the bottom equation. So we'll then have that 2x is 60 over 7 minus y equals 8. Therefore, just as before, y must be 4 over 7. So different method, same result. Question 3, 2 parts. So use a suitable method to solve the linear simultaneous equations. So by now, hopefully you've sort of seen which might be your favoured method. Personally, I would favour the approach of elimination. So we can actually eliminate both of these. So what I'm going to do here is just triple this bottom equation. If I triple the bottom one, what will happen is I'll have a magnitude of 3y on the top and the bottom. So 2x plus 3y equals 8. The bottom, I'm going to have 9x minus 9y equals 69. I can then add these equations together. So 2x plus 9x is 11x. 3y plus minus 3y cancels. 8 plus 69 gives me 77. Dividing through by 11 gives me that x is going to be 77 divided by 11, which is 7. We can then substitute this back into one of the initial equations. So if we substitute this into, let's go for the top. So now we know that x is 7. We can just pop this back into here. So then we had 2 times 7 plus 3y equals 8. 2 times 7 is 14, so 14 plus 3y equals 8. Subtract 14 from both sides, 3y equals minus 6. Divide 3 by 3, we get that y equals minus 2. So the solution is that x equals 7 and y equals minus 2. Over here, it's slightly harder because you can't just multiply one equation to get these magnitudes the same. So what I'm going to suggest we do is, again, we pick on the y's. If we double this top equation, we get a magnitude of 10y. And if you multiply this bottom one all by 5, we'd have a magnitude of 10y on the bottom. So what we'd achieve by doing that, the top equation becomes 8x minus 10y equals 8, and the bottom one becomes 30x plus 10y equals 125. Again, because now the y's are the same magnitude opposite signs, we can again add the equations together. 8 plus 30x is 38x, minus 10 plus 10y's cancel. 8 plus 125 is 133. Therefore, x is going to be 133 divided by 38, which your calculator will tell you is 3.5, or 7 over 2. We can then sub this, x equals 7 over 2, into either equation. We can put this, I would suggest, into the top equation. Just because, in my mind, the top looks simpler. So if x is 7 over 2, we get 4 times 7 over 2 minus 5y equals 4. Now 4 times 7 over 2, 4 times 3.5 is 14. So we get 14 minus 5y equals 4. We can rearrange this to obtain 5y equals 10. Therefore, y equals 2. So we know what x is, we know what y is. So the solution is that so x equals 7 over 2, and that y equals 2 as well. So the last one, x equals 1 and y equals 1 is the solution of these linear simultaneous equations. So we're asked now to work out what are the values of a and b. So what we do here, simply, we just sub in x equals 1 and y equals 1. So we just use what we're told. So we sub x equals 1 and y equals 1 into both. So when x is 1, ax is just a. When y is 1, by is just b. So we have a plus b equals 5. And when x is 1, 4ax becomes 4a. Minus by, when y is 1, just becomes minus b. We can then just add these equations together because we have the same magnitude of b's but opposite signs. So if we add those, what we're going to get is a plus 4a, which is 5a. The b's will cancel. 5 plus 5 is 10. Therefore, we see that a must be equal to 2. Now we know a is 2, we can sub it into the top equation. So a plus b is 5, but because a is 2, we now get that 2 plus b equals 5. Rearrange that, very simple. We see that b must be 3. So a is 2 to conclude, and b equals 3. And that's all there is to it. So even though this last example looked harder and a bit more confusing, it's actually not so hard as it may seem. So now what you need to do is try some of these yourselves. If you can turn to page 40, which has exercise 3a on it, and try these questions, questions 1a, c and e, and questions 2 through to question 5. You need to be mastering these and being really fluent with them. Once again, as ever, check your answers on the back once you've tried the questions. If your answers are incorrect, try and see yourself where you've gone wrong. If you can't work out why, ask a peer, a classmate, and if you're still unsure, either ask me in class, on an email, or on the comments section in this video. Thanks again for listening, and tune in for the next video next time. Bye for now.